a couple more relationships that we have that include both different shapes inscribed in a circle and two different angles that have the same arc. If we look at our first one, anytime we have an inscribed shape, which means we have all four vertices of the shape on the circle, we have some sort of rules that we can follow. If I have a quadrilateral, like I have here, which is just a shape with four sides, and it is inscribed on the circle, what it does is it creates for us a relationship that the opposite angles are always going to be supplementary. So those two angles will be supplementary, these two angles will be supplementary, and all that means is that those two angles, when we add them together, have to equal 180 degrees. So if I look here, my angle D plus my angle B have got to equal 180. I know that B is equal to 120 degrees. So the measure of angle D plus 120 degrees has to equal 180. Some quick math will tell me if I subtract 120 and I subtract 120, quick math tells me here that the measure of angle D equals 120 degrees. It's pretty simple. All I use is the relationship that opposites, again, are going to be supplementary. There we go. So I can use this one now for the blue relationship and say that the measure of angle C plus the measure of angle E is supplementary as well. If I look here, angle C, hard to see because that arrow, angle C has a right angle in it. That means it's a 90-degree angle. Plus angle E, they've got to be 180 degrees. So I've got 90 plus measure of angle E equals 180 degrees, which means my measure of angle E has got to be 90 degrees. So that's quadrilaterals inscribed in a circle. Inscribed means that all four vertices are on the circle. In my second relationship, in my second circle, I've got a relationship where I have a triangle inscribed in a circle, and the hypotenuse of the triangle is the diameter of the circle. What's nice about this is that we know that if this hypotenuse is a diameter, then this angle here, which in this case is measure of angle L, has got to be equal to 90 degrees. And we know this because this diameter cuts this circle in half, so we have an arc of 180 degrees. If I have an inscribed angle, the angle has got to be half of the arc. Half of 180 is 90. So now I can do some plugging in and solving. Measure of angle L is 6x. And I know that L is equal to 90. Quick division, if I divide by 6 and I divide by 6, I'll get that x equals 15 degrees. So I can solve that pretty simply. The last one I'm looking at here tells me that if I have two different angles, that have the same vertices, then those two angles are going to be the same. If I look at that angle, I know it's an inscribed angle of 42 degrees, which means that arc has to be 84 degrees. If this arc is 84 degrees, since this angle is also an inscribed angle, I know that it has to be half of it, which is 42 degrees. Again, those are just a couple more examples of how we can solve inscribed angles and inscribed shapes when it comes to circles, their angles, and their corresponding arcs.